Chapter 9 Carbonyl Compounds Part 1. Introduction to Carbonyl Compounds. At the end of the lesson, students should be able to give the general formula of aldehydes and ketones, functional group of carbonyl compounds known as carbonyl with a formula of C double bond O, the general formula of carbonyl compounds CnH2nO. We have aldehyde, in which the carbonyl group of C double bond O at the end of the carbon change, and the other one we have ketone, in which the carbonyl group of C double bond O is in the middle of the carbon change. Aldehyde and ketones both are highly polar, in which we have different electronegativity between carbon and oxygen atoms. Both of these also are known as isomeric carbonyl. Due to this highly polar, the carbon atoms of the carbonyl group are susceptible to nucleophilic attack. Susceptibility towards nucleophilic attack depends on two factors. The first one is the number of electron donating group, the alkyl group, and the second one is the size of the hydrocarbons. The greater the number of electron donating group, it will reduce the degree of positive charge on the carbonyl carbon, and the larger the size of hydrocarbon, it will cause a greater steric effect, in which at the end, nucleophiles are difficult to attack the carbonyl carbon. By comparing a general structure formula of aldehyde and ketone, we can see that presence of one alkyl group in aldehyde and two alkyl group in ketone give an aldehyde more reactive than ketone towards nucleophilic addition reaction. Nomenclature of Carbonyl Compounds. At the end of the lesson, students should be able to draw structures and name aldehydes and ketones according to the IUPAC nomenclature. Naming aldehyde and ketone. For aldehyde, substitute the letter E of the corresponding alkane with Al. Ketone, substitute the letter E of the corresponding alkane with O and E. For the parent change of aldehyde, the longest change must have a CHO group. Ketone, the parent change, in which the longest change must include a carbonyl group of C double bond O. For aldehyde, the chain must be numbered by starting with CHO group as a first carbon. And for ketone, the chain must be numbered so that carbon in a carbonyl group of C double bond O gets the smallest number. A few examples of aldehyde, starting with one carbon, the IUPAC name of methanol and a common name of formaldehyde. The next one, aldehyde with two carbon, the IUPAC name known as ethanol with a common name of acetaldehyde. The third example, we have 1, to 3 carbon atom as a parent chain and 1 methyl group as a substituent. The IUPAC name for this example 2-methyl propanol. The last example, we have 1 carbon chain as a parent chain and a benzene ring as a substituent. The name for this substance, phenyl methanol, or known with a common name of benzaldehyde. A few examples of ketone. The first one, we have 1, 2, 3 carbon atom as a parent chain with IUPAC name propanone, or known with a common name of acetone. The next example, starting with the first carbon on the right hand side, we have 1, 2, 3, 4 and 5 carbon as a parent chain. The IUPAC name for this structure 2-pentanone because of carbonyl group located at the second carbon. The next example, we have 1, 2 carbon atom as a parent chain and benzene ring as the substituent. The IUPAC name for this example, phenylethanone, or known with a common name of acetophenone. The last one, we have 1 carbon atom as a parent chain bonded to 2 substituents of a benzene ring, known with a IUPAC name of biphenylmethanone and a common name of benzophenone. The end of part 1.